All right, scholars, give me just a moment. Let me see my captions, confirm. I see people joining, so I know that it works. So I'm just going to kind of go with it. Yeah. So I know it's being recorded. I've been kind of like updating my my YouTube playlist. That's what I was working on. It's part of the reason why I'm a little bit late. I know these sessions are recorded. Yeah, I don't know why other students like have such a hard time finding this, and like especially because I went out of my way to make sure it's the same room each week. So it's like for whatever reason, I think that people are not downloading the app. They're not following instructions. I think if you just download the app and then join our team or whatever, then it's an easy connection. But again, I just move forward because that's part of the reason why I recorded, so that way once they do find it, then they can always watch the recording and it's available. No real announcements. I think we're just moving into chapter 11. Let's see. Chapter 11 is on counting methods and probability theory. So I think you guys are okay. I'll just do it anyway. Okay. I'm going to kind of hold off on this one because if you guys can add yourself, that'll be great. Because I've just kind of structured it to be that way. Okay, so chapter 11, counting methods and probability theory. Yeah, so when I first came across this topic, I was like, what? Counting is an actual topic in mathematics? Then you think about it, obviously counting, yeah, I was like, okay, well, I guess that makes sense. But it seems so simple and trivial, but then, it can get kind of hairy fast, right? Like, okay, you got you got a group of apples, how many apples you count, right? But then what if it was like, well, how do we make sure that every citizen can have a license plate? You see what I'm saying? Like you want each person to have a unique license plate. So then what's the how do we build the license plate so we know that we can cover our citizens, all right? So then that means what? Doing a census and getting a sense of how many people live in the community or whatever, or in the city or however large you're trying to go for. And then how can you construct the license plates so that each person can have a unique license plate, right? Because you don't want any duplicates. Like it's stuff like that. It's just random stuff like that. So I was like, it was kind of interesting. It's a little bit random to me, but it is interesting and it seems apt or relevant as far as mathematics. So counting techniques and some of the different scenarios that come out. Okay. And then how counting leads into like probability, right? Okay, so let's look at it. So we're going to introduce this concept with section 11.1, the fundamental counting principle. And our objective here is to use the fundamental counting principle to determine the number of possible outcomes in a given situation. So we're considering the total number of possible outcomes here. So a definition, if you can choose one item from a group of n items, give me just a moment. I think you guys are okay. Yeah, you're looking good. Okay, cool beans. Yeah. I'm still going through like my documents. I'm really trying to get caught up on my videos, the YouTube videos, so that that can just be up to date. It seems like people are able to join, so I'm going to let the lobby kind of be. So definition: if you can choose one item from a group of n items and a second item from a group of n items, then the total number of two item choices is going to be m times n. So one way to kind of visualize this is with a tree diagram. It's a representation of all possible choices. This tree diagram shows that there are 2 times 3 equals 6 different outfits from 2 pair of jeans and 3 t-shirts, right? So this person has 2 different jeans and 3 different shirts, and he's like, okay, how many different combinations can I make with these 2 items? So then you see, let me see. Right here. And this one. Oh, that's collapsed. All right. So his first choice, like he's choosing, he has 2 pants to choose from, and then for each of those, he has 3 different shirts to choose from. So when you notice that energy of for each of those, that means multiply, right? So we have 2 choices in the first slot, and then for each of those choices, he has 3 shirts to choose from in the next, right? So then the total possible outcomes is going to be 2 times 3 to give us 6. So six different outcomes. All right. Okay. Let me see. The Greasy Spoon restaurant offers 6 appetizers and 14 main courses. In how many ways can a person order a 2-course meal? Right. So appetizer and a main course. So he has 6 different appetizers to choose from, and then for each of those, he has 14 different main courses. So like if we were doing a tree diagram, right? You have appetizer 1, and then he has 14 options there. Appetizer 2, and then 14 options. So that puts it at like 28. Then what? Whatever the next one is, right? So long story short, the total amount of 2-course meals is just going to be 6 times 14. So 60 plus 24 is 84. So 84 possible outcomes. I feel like Count Dracula. 84. I don't even know if y'all know who that is. That's from Sesame Street, right? Throw back. So the fundamental counting principle with more than 2 groups of items, right? But again, I think this is still the same concept going on here. It's like, for each choice in the first slot, you have X amount in the second slot. And then, but for each of those, you have another number after that. So every time we have this urge to say for each of those, we multiply, right? So the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. The number of possible outfits from 2 pairs of jeans, 3 t-shirts, and 2 pairs of sneakers. 2 times 3 times 2 is 12. All right, and I think we can see all 12 here. So then with those 6 different outfits, if he has 2 different pairs of shoes to choose from, so then, just multiply by 2. Okay, let's keep going. So next semester, you are planning on taking 3 courses, math, English, and humanities. There are 8 sections of math, 5 of English, and 4 of humanities that you find suitable. Assuming no scheduling conflicts, how many different 3-course schedules are possible? I think we kind of get the theme of the section, right? Basically just multiplying. So 8 sections of math, you can take section 1 of math, and then you have 5 choices of English. So say you take 1 math, 1 English, then you have 4, right? Long story short, 8 times 5 times 4. We could do a tree diagram, but it'll get kind of extensive, right? Because we'd have 8 branches, and then 5 from each of those branches, and then 4 from each of those. 5 times 4 is 20. 8 times 2 is 16, so it's a total of 160 possible 3-course schedules that you can choose from. Like, I guess we saw one with a restaurant. Like, I think, like, I saw one before that was like, if you have a ice cream parlor and you have, all these different flavors, how many different combinations can you do with these toppings and these ice creams, right? So then you have like over thousands of different possible combinations to choose from, right? This one was 116. Okay, let's keep going. We're pretty much done with this section. I mean, like it was a breeze. So we'll go right into the next section after this. So multiple choice test. You're taking a multiple choice test that has 10 questions. Each of the questions has 4 answer choices with 1 correct answer per question. If you select one of these 4 choices for each question and leave nothing blank, in how many ways can you answer the question? Let's read this again. You're taking a multiple choice test that has 10 questions. Each of the questions has 4 answer choices with 1 correct answer choice per question. If you select one of these 4 choices for each question and leave nothing blank, in how many different ways can you answer the question? Okay. I kind of want to do this one in this way. So we have a 10 question test, right? So like say this is question 1. Let me see. We can go a little bit thicker. That's good. Copy, paste. So that's question 1, question 2, paste. 3, 4, paste. And let's just copy and paste. Okay, so each box basically represents a question, right? So say we have like question 1, question 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's copy. I like this one. Copy and paste. That's one. Okay. So each box represents a question, right? So then for question 1, let me think about it. So how many different choices, how many different options do you have for question 1? Well, you have 4 options there, right? How many options do you have for question 2? Basically, each question, I think we have 4 options, right? So then how many different ways can you answer the questions? If you multiply these, it's going to be what? 4 to the power of 10? Let's use the calculator. I think that's right. No, what did I hit? Something wrong. Let's go back here. We can close that, and we are here. Okay. Oh, I totally forgot to do my screen the way I normally do it. I'm just going to go with this for today. Not going to worry about it. Oh, come on. Thank you. I was like, don't make me load that again. Okay. So let's see. I think that's right. 4 to the power of 10. So 1,048,576. Different ways to answer the exam. Because every time we choose something for question 1, we have 4 options in question 2. But then for each of those, we have 4 through. But then for each of those, so each of these steps are all for each, right? So basically, we're multiplying at each step, right? But this one was constructed. I mean, this is one of the ways to kind of count these kind of scenarios. Let me change my view. Single page. I think you guys are okay. I'll let it be. Yep. So that's what we got. Okay. So telephone numbers in the United States begin with 3-digit area codes followed by 7-digit local telephone numbers. Area codes and local telephone numbers cannot begin with 0 or 1. How many different telephone numbers are possible? So what I'm going to do, I'm going to pull 7 of these guys, these boxes that I just created. Copy. Paste. Okay. So these represent the digits in a telephone number. The first 3 are the area code. Right, from here to here. And then this is a local telephone number. Local number. From here to here. Okay. Let's see. 3-digit area code followed by 7-digit local telephone number. Area codes and local telephone numbers cannot begin with 0 or 1. How many different phone numbers? Okay. So if we consider the area code, how many options do we have for that first digit? Well, remember that first digit can't be 0 or 1. So normally it would be 10, but we have to knock out 0 and 1. So then that leaves us with 8 different options. I mean, it seems like you guys are okay. People. Let me just let them in. I don't know. It seems like some people are able to get in and some aren't. It's kind of weird. Okay, so we have 8 options for that first digit, and then, but the second 2 can be any digit, right? So we have 10 options here and 10 options here. And then it also says that the local number, wait a minute. I think we do need all 10. Okay, I didn't do that right. I just need like 3 more. Copy and paste. Okay. That's fine. And this again, this is the local telephone number. So here to here. Okay. So then again, with the local telephone number, it can't begin with the 0 and 1. So that first digit in the local number, we only have 8 options to choose from. And then the remaining could be any digit. So we have 10 options here, 10, 10, 10, 10, and 10, right? So say we're constructing a phone number. We choose a digit we choose one of the 8 from the area code, but then for each of those options, we have 10 in the next one, but then for each of those is 10. So long story short, we multiply all these out. It's basically going to be what? 800 times 1, 2, 3. It's an 8 with 6 zeros. So that's a 64 with a total of 8 zeros. I think that's right. 1,000 million billion. 6.4 billion possible telephone numbers. That should be enough, right? I think the world population I'm pretty sure we're way past 7, probably closer to like 8 or 9. I don't know. With all this war going on, it's so disgusting. I don't want to think about it. And like, we're on the brink, of world war. So buckle up, buttercup kind of thing. Yeah. I think it's really important though. It's a good idea to start learning how to become self-sufficient, and it's in the form of like growing your own food, cleaning your own water. I know it sounds disgusting, but that if you can figure that out and do it correctly, and you have the resources or connect with people that can do it, that's a good move. If you have some land, stuff like that, like being able to do for yourself, generate your own power, defend yourself, grow your own food, stuff like that. I think that's really important in this next few years, it seems like. Anywho, all right. So this is how many different telephone numbers that we can generate. 1,000 million billion. I think we got 6.4 billion. 1,000 million billion. All right. Okay. So that brings us to the end of 11.1. We did that in record time. So I'm going to go ahead and pull up the next section.